Good morning, everyone. My name's David Lapsley. I'm an engineering manager within Cisco's Core Infrastructure as a Service group. We're responsible for developing, deploying, and maintaining OpenStack. The product that we look after is actually called Metapod. So if you're interested in what we do, you can go to cisco.com, you can do a search on Metapod, and you'll actually see the product that we maintain. Today, what I'd like to talk about are some of the best practices that we've developed in doing test-driven development with Ansible for OpenStack deployment. So this work has actually been led by my colleague, John Dewey over there, who's one of our technical leads. And he's been working with a team of folks that you can see here, Adam, Duncan, and Rami, on developing a workflow and tool chain that enables us to do TDD for Ansible deployment and development. So I'm actually a consumer of the stuff that they've done, because it turns out that the work that they've done to make it easy to develop Ansible playbooks is actually something that we can also use for developing OpenStack. So the challenge that we're trying to address is this. It's actually really hard to write reliable, robust, and maintainable infrastructure code for OpenStack deployment. And by infrastructure code here, I mean specifically Ansible. And there's a number of reasons for that. So one reason is that OpenStack is actually a really complex distributed application. If you just look at the application itself, I wrote a really simple script that basically went onto our controllers and captured all of the configuration parameters that we use for every single OpenStack service. There's more than 1,830 of those, and that's just for the application. A lot of these configuration parameters actually have a major impact on the behavior of your cloud. So for example, if you look at nova.conf, you can specify what virtualization driver you want. If you look at Neutron, you can specify what networking model you want to use. Even small parameters like timeouts can have a major impact on the reliability of your cloud. So not only is OpenStack complex, but it also turns out that if you're running OpenStack in production, configuring the application is really just a small part of what you need to do. There's a whole bunch of other work that you need to do to be able to configure and maintain your cloud. So if you look at any node within your OpenStack cloud, you'll see something like this. So there's a stack of things that need to be configured, orchestrated, maintained. So at the bottom there, we have the kernel. So for networking, for example, we need to tune TCP send and receive buffers to make sure we have performant TCP connections. You have the base OS, making sure that you install the right packages to be able to support your deployment. And then on top of this, you have a bunch of additional services. So simple things like DNS or NTP, for example, which are really crucial to the operation of the cloud. But then there are other things that are even more complex than that. So your monitoring system, the alerting that you actually use to make sure that you're able to maintain your OpenStack cloud in a supportable way. And then on top of all of this, you have the OpenStack application itself, which is also super complex. So it turns out that the amount of infrastructure code that you need to develop is substantial. And if you're not careful, it can easily grow out of hand. So just to give you an example, this is a list of all of the Ansible roles that we currently have for deploying OpenStack. So each of these is a directory. In a little while, I'll go through in more detail the contents of each of these directories. There's a lot of code there. And if you're not careful about the way you develop this code, the workflow that you use, the tools that you use for doing testing, then it's really easy to quickly have a large code base that's unmaintainable and that's brittle. So you don't know whether or not changing the code base is going to break something. You don't know how to actually test it. There's no really good way to be able to test it. And so that's why our team has actually developed the Molecule tool. It's basically a command line tool, and it makes it a lot easier to do test-driven development with Ansible. Here's the Molecule workflow. So we take the Ansible role that you're currently developing. We take either test infra or server spec tests that have been written, and then we have a Molecule playbook, which specifies how we want to test this role. So how we set up a virtual environment to be able to test it, any actions or any parameters that we want to pass through to the Ansible playbooks to be able to test the roles that we're working on. So Molecule takes all of this, it passes the information to a provider. In this case, we're looking at Vagrant, but we're also working on other providers like OpenStack and also EC2. Vagrant will then create one VM or more VMs so that you can have a test environment. It'll then call Ansible through the provisioner API to execute the test playbooks or test roles so that you can set up the environment the way you would actually set it up in production. Once it's done that, it will actually execute all of the tests that you've defined against that virtual test environment, and you can see whether or not your tests pass. So here's a look at some of the commands that Molecule has. So you specify, when you run Molecule, you specify the command, you specify an optional host, a platform, so whether it's Red Hat or Ubuntu, a provider, whether it's Vagrant or EC2, and then tags to be passed on to the Ansible roles. There are a number of different commands, so you can create the instances. So this will spin up your virtual test bed. You can do a converge, which will create the instances, run the Ansible playbooks, and basically provision your virtual environment. You have an idempotence test to make sure that if you run your playbooks multiple times against the same test bed, you get the same result. You have test, which is used as part of our CI. That will actually destroy any existing virtual test environment. It'll create, converge, and then verify the results. You have verify, which is what you would normally use as part of your development workflow, where you basically create the test bed, run the Ansible playbooks, and then test that the instances are actually deployed the way you think they're supposed to be deployed, checking for packages that have been installed correctly, services that are up, users that have been created, and so on. You're also able to see the status of the instances that you currently have, list the available providers and platforms, and also you can log in via SSH to instances that have already been provisioned. The Molecule playbook is what enables us to specify how we want our test environment to be set up. So it looks like just any other Ansible playbook at the moment. We're actually working on making it easier so that it looks like just any configuration file. But even here you can see it's pretty straightforward. All you do is define a molecule section within your variables. You can see we've got Vagrant there for the Vagrant provider. We specify the platforms. In this case, we're looking at RHEL 7, so we have the name, the box, the URL to download the box if we don't have it locally. We have additional parameters, so the instance group name to be applied to all the instances, and then we have a list of instances as well. And these instances, in this case, it's just one, but it could be many. It could be, we could have a list of instances for controllers, for hypervisors. We can stand up an entire OpenStack cluster using a Molecule playbook. In this case, we're just testing a single role. So it's Cisco.common, which is a really simple role. All it's doing is installing some packages. So you can see that we have a users section there. All of that information is just going to be passed into the Cisco.common role, which is then going to, in this case, create a user with all of the attributes that have been specified there. So now we can actually use Molecule to start building our infrastructure code. So this is the Cisco.common directory. So for those of you familiar with Ansible, it's basically follows best practices for Ansible. We have a README file there, a Vagrant file that's used by Molecule. We have a defaults directory, which is used for storing default variable values. We have a set of handlers for managing events in Ansible, metadata for capturing information like dependencies, dependent roles, the Molecule playbook, the task, which is actually the orchestration tasks that need to be executed. We have the tests that we want to define using server spec or test infra, and then we have any other variables that we want to include as part of that role. Here's an example of what a test looks like. So this is a test infra test. So we have a couple of variables. We have the test infra hosts, and we have a list of base packages. All the test is just a Python function that has the prefix test on it. That gets executed when you run Molecule verify. So all this is going to do is iterate through all of the base packages. It's going to create a package object, and it's then going to assert that that package object has actually been installed. So it's a very simple test. We have some similar tests, so these tests are for testing that Red Hat packages have been installed, if Red Hat is the operating system, or that Ubuntu packages have been installed. This is what our actual task looks like. So it's very simple again. So basically, if the Ansible OS family is Red Hat, then we include the subtask Red Hat packages. If the Ansible family is Debian, we do the same thing, but for Debian. So the Red Hat packages looks like this. So basically, each one of these stanzas is responsible for looping through a list of packages and then installing those packages. So if we look at the top one there, install common packages via yum, that's an Ansible loop. So the with items section basically means that we're looping through all of the common base packages, And for each of those, we're calling the yum module with a name equal to the name of the base package. And then we're setting its state to be whatever common package state variable happens to be. In this case, it's going to be present. So basically, we're just installing those packages. We do the same thing for Common OS specific packages, for Apple packages, and so on. So this is the defaults directory. And so basically, this is where all of the variables that are used on the previous slide are shown. So now we have our tests, we have our molecule playbook, we have our role. We can actually put it all together and run molecule. So we do a molecule converge at the top of this page. If you look at that trace, what you'll see is that it's actually creating a virtual machine, standing it up. The next thing that it does is run the Ansible playbooks. And so you can see all the tasks, and at the bottom of the page there, we finished running Ansible. Then we run molecule verify. And so you can see that in this case, all 6 tests have been run, and they've all passed. One of the really cool things about Molecule is that we can use it for OpenStack development as well. If you look at the workflow, basically we're using the same Ansible roles we're using in production to stand up a virtual test environment. So we can stand up a virtual OpenStack cloud with multiple controllers, multiple hypervisors that looks exactly like the way we do it in production. We can actually use that for OpenStack development, which is really cool. So just to summarize, Molecule, we've developed Molecule to enable us to do test-driven development for infrastructure code. It looks a lot like Test Kitchen, which is used for Chef. It integrates with both server spec and also test infra, so there's a lot of flexibility in terms of how you define your tests. It enables us to do large-scale and complex role development and to keep our code bases maintainable. And then it also has a really nice side effect that on the OpenStack engineering side, we can also use Molecule for provisioning our development environments. We're currently in the process of making Molecule open source. If you have any questions, please feel free to email either John Dewey or me, and we'd be happy to talk to you. If you have any questions after this, we'd also be happy to talk to you outside and answer those questions. Thank you.